Hello friends, welcome back to my YouTube channel. This is Ramdas Pandit Barsat, working as Assistant Professor in Chemistry at Maratha Vidya Prasarak Samaj, Nasik. In this video lecture, we are going to study about complexometric titration. This is the next type of titration, and as we know that in the complexometric titration, the complex forming agent is one of the important factor. So we should know about the complexing agent, and we have known EDTA is the one of the important agent in the complexometric titration. So first of all, we have to know about the complexing agent. So definition of complexing agent, that is the groups bound to the central metal ions or ligands termed as complexing agent. Suppose if we want to calculate the specific amount of specific elements, so for the determination of that elements we have to use that EDTA agent, okay, or you can say that is complexing agent. You will see the reaction in this way, that is metal, okay, it will be in a hydrated form, okay, and plus L, capital L, that is the L stands for neutral molecules or ligands, okay. Now M in bracket water molecule is there in -1, okay, L plus H2O. So like this complex will form after the addition of complexing agent with a metal, and for this process we call them complexometric titration. So in this case you will see determining the concentration of individual cations in a mixture are known as complexometric titration. Individual cations, that may be calcium, that may be magnesium, that may be sodium, okay. So depends on the valency of complexing agent, we can determine like this cations, okay, like these elements with the help of this complexing agent. So as I told to you, EDTA is one of the important complexing agent. We have to see about the EDTA. The EDTA stands for ethylene diamine tetraacetic acid. It is a hexadentate ligands. Okay, it can form bond at least 6. Okay, that means you will see here this ligand can use as a titrant. In the titration, we have no number of terms are there. So titrant we can use as EDTA. Okay, it forms stable octahedral complex with many metals ions in the molar ratio, that is 1:1. Okay, so that EDTA will form the complex octahedral, that is shape of this complex octahedral shape is there, okay. It can form the complex with the metal. It may be magnesium 2 plus, it may be calcium 2 plus, okay. And in this kind of complexometric titration we have to use this indicator, that is erythrochrome black tea indicator, okay. That is we have to use as an indicator in this titration. You will see the reaction, okay, M indicator plus EDTA, and it will form the complex this way. M metal, okay, M stands for metal, okay. So that metal will form complex with the EDTA, okay, and the indicator will be side product will be there, okay. So in this way we have to see it can be used as titrant in the determination of metal ions like magnesium, manganese, zinc, cadmium, mercury, copper, aluminum, iron, cobalt, nickel and platinum. So like this elements we can determine with the help of EDTA, okay, in the complexometric titration. In this way, we have to see magnesium EDTA complex, okay. So in that, use of EDTA as a titrant in this titration, and in this titration we have to determine the magnesium, the quantity of magnesium, okay. So as a titrant we can use EDTA, and Erichrome black tea is used as an indicator for this titration. So the initially metal indicator complex can form, but it is less stable, okay, than metal EDTA. So complex form during the titration, okay. So before the formation of metal EDTA complex, it it can form metal indicator complex form, okay. So that complex is very or less stable, you can say, okay. So then metal EDTA complex, so you will see the reaction metal indicator plus EDTA, it gives metal EDTA plus indicator. So like this complex will form when you add the indicator, metal sample, and in the EDTA, okay. So in this way metal EDTA complex will form. So the most of the time in this kind of titration, magnesium 2 plus ions use. And when you are doing the complexometric titration, the times when you will standard EDTA solution is added to the metal indicator. So complex will form there, metal indicator complex will form, the metal EDTA complex form, and free indicator is released. We have seen the reaction. First of all, you will add metal sample with the indicator, so it will form the complex. After that you will add the EDTA solution, so the metal indicator complex is very less stable, so it will disturb after the addition of EDTA solution, okay, and that metal EDTA will form, okay, and that free indicator will be released from this solution. So at the equivalence point, color change is observed from red to blue. That is the end point of this titration, complexometric titration, that is the end point. So in case of magnesium, the amount of magnesium can be calculated by using this relation, that is 1 ml 0.1 molar EDTA is equals to 2.432 milligram magnesium. So with the help of this relation we can calculate the magnesium amount. Now EDTA can be used as titrant in the determination of metal ions like magnesium, manganese, zinc, cadmium, mercury, lead, copper, aluminum, iron, titanium, cobalt, nickel, and platinum. So if we want to calculate the amount of this kind of elements, okay, if you want to determination of this kind of metal, so the time we can use titrant, okay, EDTA. Now we have to see the types of EDTA titration. So in this case they are divided into two types. Direct titration. First of all we have to see about the direct titration. In this case you will see the solution of the metal ion to be determined is first buffer to a desired pH by using the suitable buffer. We have no buffer solution we can use for the control the pH, okay, desired pH, that is the suitable pH okay, to determine the ions. And in this direct titration, we have to we can add the ammonia buffer, okay, to control the 10 pH and titrate with the standard EDTA solution. So at the equivalence point, the concentration of metal ions decreases fastly. Okay, so equivalence point, that will be the end point of this titration. So at that stage, the metal ions will be decreased fastly. So this is the indicated by the equivalence, the color change of the metal indicator, or by suitable instrument method like the amperometry, spectrophotometry, or potentiometry. So in this titration, the equivalence indicated by the color change of the metal indicator, and we can also see with a suitable instrument that are given, that will be the amperometry, okay, potentiometry, and spectrophotometry. Now we have to see the next type, that is back titration in the complexometric or by using the EDTA solution. So in this case, the back titration in which an excess of standard EDTA solution is added, the resulting solution is buffer to the desired pH and the excess of EDTA is back titrated with a standard metal ion solution. So in this kind of titration, if you will add the EDTA solution large amount, okay, so that times EDTA is back titrated with a standard metal ion solution. And usually a solution of magnesium sulfate, magnesium chloride, and zinc chloride, zinc sulfate is often used for this purpose. So in this kind of solution we can use for this kind of purpose. The endpoint is detected with the help of metal indicator, which responds to the zinc or magnesium ions introduced in the back titration. So in the back titration, you will see the endpoint is detected by the help of metal indicator responded to the zinc or magnesium ions. Okay, as we know in the direct titration, so the color of the metal will change at the equivalence point at the end point of this titration, but in this case you will see metal indicator is helping to the detect the end points.